hard to turn on the news or pick up a paper or read about technology, business, and public interest matters without the dialogue turning towards AI or artificial intelligence. We see and hear stories about it, and they're usually accompanied by pictures of robots like this, or even this. But none of that is artificial intelligence. It sometimes feels like the realm of science fiction has entered everyday life. But stories like that are generally widely missing the point of what AI actually is. In this course, AI for Anyone, I'll take you on a journey where you'll unlearn everything you think you know about AI, and instead you'll end up in a place where you understand what it really is, and just as importantly, what it isn't. I'm Laurence Moroney, and I lead AI advocacy at Google. It's my job and my passion to train millions of software developers to understand machine learning, deep learning, and artificial intelligence. But the promises of AI aren't just for developers. We can all benefit from it. And with that in mind, we created this course as an introduction to AI for everyone and anyone. Now, hopefully, once you're done with it, you'll have a better grasp of the opportunities and not be caught up in the hype. And that's where I'll start this journey into artificial intelligence, by helping you understand the hype. This chart is a rough outline of the Gartner hype cycle. Now, typically, it starts with a technology trigger, which leads to a peak of inflated expectations. This peak is when the dialogue and the vernacular around the technology is generally driven by ignorance around that technology, maybe even fear about what it might supplant, or doubt about its capabilities. It's something that happens often when new technologies are introduced. Think about the advent of the personal computer, the internet, the smartphone, or any other technology, and realize that there was a peak of inflated expectations around it. Do you remember Y2K? That was in the early days of the broad internet, when people were getting used to having an interconnected society, and that a feature in how computers in the old days were programmed for 2-digit dates could bring the entire world down when we had to go to 4-digit dates in the year 2000. Now, that was a great example of fear, uncertainty, and doubt as part of the peak of inflated expectations as the world was getting increasingly online. And that's where we are today with artificial intelligence, primarily driven by the same factors that I've just mentioned. My goal for this course is to help you to understand what the technology is all about, because when you do, you fall into this part of the hype cycle. It's called the trough of disillusionment, which can sound a little bit depressing. But it is a necessary step. When you break out of the hype and you can understand what you can really do with the technology and how it really works, then you can begin to understand the possibilities with it, and that will help you rise up to the plateau of productivity right here. And if you've ever wondered how those who've been able to innovate with the introduction of new technologies, and they are the ones who come up with the great ideas that change the world, well, here's a little secret. They're not necessarily smarter than the rest of us. They're just further along this curve, and they're already being productive here, while others are stuck in the hype here. I'd love to share one example. Recently, I got to work with the producers and actors from a famous TV show called Stargate. They were interested in what an AI could write script-wise, and they were generally fearful that this could put them out of a job. They were very much caught up in this peak of inflated expectations. So I worked with them to train a set of AI models that could create new content for their show, and we had the actors do a reading. Now then, when they saw how this story generated by an AI lacked direction and often veered into sublime and bizarre directions that no story writer would ever take, we saw that the issue wasn't the AI, but the hype. Then one of the actors came up with an idea. Screen tests are a very difficult task for actors. And having a model generate text in the vernacular of a particular character, particularly really difficult text to read, would give them a way to practice ahead of stressful tests. It would help them with the verbal gymnastics that they often have to do, and they usually can't pay a writer to create new text for them ahead of an audition. So this actor went from the trough of disillusionment to the plateau of productivity and came up with a great idea for a whole new class of application powered by AI. Now, he may never be a developer, but he's gone ahead in the curve to the extent that he has an innovation that might be useful to many. And that's my goal for you in this class. So let's dig in and get started. Let's first come up with a definition for artificial intelligence. Now, there's lots of ways of describing it, and many of them, thanks to the hype, can be misleading. So I'm going to start with this one. Artificial intelligence is the technique of programming a computer to respond to data in the same way that an intelligent being does, or at best, to simulate how an intelligent being reacts to, processes, and understands data. So when a computer sees an image of a cat, instead of just seeing the pixels like this, it could actually understand that the picture contains a cat, just like this. Note that I mentioned that it's a technique for programming a computer. Now, this is very important, so let me spend a few minutes on it. Typically, a programmer creates a computer program by coming up with a set of rules, expressing those rules in a programming language, and then having a computer execute those rules. So, for example, consider the game of noughts and crosses or tic-tac-toe. If you wanted to program a computer to play this game, you would have to come up with a way to express the rules to play and win the game. And even at a high level, before you write any code, you might have rules like, if you're going first, then go to the center. If the other player went first and now it's your turn, you should go in a corner. And if the other player has two in a row, then you should go to the position that blocks them, and so on. There's a lot of rules, even for a very simple game like this. But most people don't play the game or don't learn it by being told a list of rules and then following them blindly. You play games with your friends, you play with your family, and then you learn from experience the rules and the strategies to play the game effectively. And that's the first key to building computer applications that act like intelligent beings. You have to train them the way you train an intelligent being to do something. So instead of you writing code that acts on the data to come up with the answers, I like to represent it like this. You'll instead come up with lots of examples and then have the computer do what computers do best, and that's churn through all of the examples to figure out the patterns. And once they have those patterns, they could turn them into a model that can be used to understand future patterns, and then, for example, in a game, to determine the next best move. And I like to represent that like this. It's very similar to traditional computer programming, but it's just a different way of thinking about it. But where this gets really powerful, and what the excitement is all about, is when you use this to solve problems where it's impossible for you to figure out the rules. It's very easy to figure out the rules for noughts and crosses or tic-tac-toe, but what if I showed you this image? Could you tell the person's age simply by looking at this picture of their retina? I doubt it. And even an ophthalmologist may not be able to do that. They could maybe figure out a diagnosis of a disease, but they couldn't figure out the age. And even if you could, how would you express that with rules? And that's what makes the realm of artificial intelligence, machine learning, deep learning, and all of those concepts so exciting. It makes it possible for us to build a type of computer programs that were not previously possible because we would have had to come up with rules that we could program a computer with. Now we can help computers do the seemingly impossible, like ascertain a person's age from a retina scan. So even if you aren't a programmer, like my actor friend, you can be a part of this revolution by getting into the position of knowing what's possible and applying that to your area of expertise. So please come and join me on this journey. We'll start with the lifeblood of an AI application, which is data, and we'll look into that next.